Welcome to Level Up Africa. Today we're going to take a look at the Unity editor and learn about development, particularly around programming, either with the C# programming language or with the visual scripting that you can do inside Unity. So what we're going to cover, we'll do some brief introductions about who we are, then we'll take a little step back from programming and just talk about game design principles, just so we know where and why we're adding our code into the project. And we'll look at what are the different ways you can do coding. Now, traditionally, coding in games was manually typing out letters into the code base, and that's how your code would enter into the project. That still is where the majority of the effort is done. But Unity and some other tools like it have offered more and more visual ways to do drag and drop behavior. So we'll take a look at a few different ones of those today. We'll take a look at demos of them inside Unity as well as learning the theory. So my name is Sam. I'm from the US. I'm currently in Nairobi, Kenya, and I'm doing some teaching and some learning all around the game industry in Kenya and particularly in Nairobi.
I'm Brian the Beest. I'm from Kenya. I'm a professional gamer, gaming mentor. If it's video games, I'm all about it.
Nice. So in the Level Up Africa program, we're here to build community around the game development industry from all aspects, particularly from esports on Brian's side and community building to game dev and education from my side and seeing what we can create here together as we go. So we will look deeply at the sample project that we've got. We'll take a look at some different ways you can program inside Unity. And there's a free sample project included along link below. You can open it up inside the free Unity editor and follow along. And if you're particularly inspired about what you're seeing, you can tweak the project and use it as a learning tool. So let's talk a little bit about game design. So Unity tends to be used in the second half of the software development lifecycle. That is where you do your development, including what we're going to show right in this video, as well as play testing the project and finally deploying it. So probably when you're a professional getting down to your day doing your job, there's probably been some planning and design that is done before you even start your coding. That's kind of the North Star that you follow as you're doing your coding along the way. So let's take a look at the game loop that is typically used in game development. So Brian, when you first see this is the classic game design loop. Does anything seem familiar to you, or do you have any questions about it before I explain it?
Action, reward, expansion. Let me try. It's just like a 2D game like Super Mario.
Mm-hmm.
The first thing you see is that, like, for you to move, you have to put the action of movement.
Perfect.
So when you start that action of movement, what you get is there is coins and there's the mushroom. So I think that falls in the reward section. So either you chase after it, or either you knock on something, so it gives you, what do we call it, the item, the reward. And then the expansion is maybe when you finish the level and then go to the next level.
Sure. Also, I would even say the mushroom, and you gave a great example. The mushroom, since it changes your ability to do actions, you're more powerful, you can jump higher, etc.
Yeah.
That's a reward and also expansion. So perfectly done. 10 points. So the example I will use is with Pac-Man, the classic game, that with Pac-Man, you use user input, like a traditional joystick to move the character around. He's collecting the regular small power pellets for points, and then occasionally you get the bigger pellets which expand your abilities. In Pac-Man, you can temporarily consume the enemy and kind of turn the tables on them. Yeah. You become invincible. So that's a typical example. Now, that's it. This is what game design is. You're just looking at this simple loop and trying to make interesting types of actions that give the user some engaging rewards. Most game developers are good at those two steps, but you need to also think about ways to expand the gameplay. So going to new worlds, as Brian mentioned, which is of course part of gaming, as well as being able to do new things with new abilities like the mushroom example that he gave. So with that in mind, as kind of the context for programming, when we sit down to do our programming, there is some different types of scripting. So starting with the visual scripting, there is the ability to write really all of your gameplay code, completely replacing the manual typing if you wanted to. You can do all of that with Unity's visual scripting. Now, probably on any professional team, they're not doing the complete game in visual scripting. While it is equally powerful, it is a much slower process. So more often, teams use it as a learning tool. So when you're a very beginning programmer, you might use the drag and drop functionality that we'll take a look at. But as a mature programmer, you would learn to type out the code manually. The manually typed code is always more flexible and more quick once you're good at it. Whereas the visual one is more easy to get started. It's easier because you don't make as many errors. It kind of puts your whole experience on some rails so that you're a little bit protected. So that's why it's useful for learning. Now, there's 3 categories. Now, typically Unity only talks about visual scripting as this first orange box here, but I also see a couple of their other tools also like visual scripting. So shader graph is a graphical representation of how shaders work in your game. We'll talk about what shaders are, why they're important, and why shader graph is cool. That's used to create shaders. And then VFX graph is used for visual effects. You can drag and drop behaviors just around creating particle effects like smoke, fire, bullets, and stuff like that. So we'll take a look at all of that here. All right, so visual scripting. Let's take a look at just what it does for us. So it's a series of drag and drop cubes that each represent common programming things. You'd imagine one cube that is take the input from the keyboard, and another one is move my character, and you drag connector lines to them to make the right relationship. Because it's very visual, and you're given this list of potential drag and drop objects, it's friendly and safe as a new programmer to start dragging and dropping behavior out there. But again, probably after you create your first project in that, you then learn the power and the depth that manually typing the code does for you. What's really happening under the hood here is that each of these blocks represents a chunk of code anyway. So in a way, this is helpful, but unnecessary for mature programming. Another nice tool here is that if you're a programmer used to manually typing all day, but you want to have your game designer be able to tweak some of the game rules, you can have just a small part of your game be represented in this visual way so they can interact with it. Right? So you can think of it like creating mods or something, which is the example Brian gave earlier. Creating mods for a game is a way to take an existing complete game and has some friendly tools to tweak it. You can basically give your coworkers that as well. So some of the different things that you can do, some of the features, you can create script graphs where you're doing the gameplay logic. You can create state graphs, imagining that your enemy can have a patrol state, and then a chasing you state, and then a shooting at you state. There are different subsections of his possible behavior. Some other benefits, you can do live editing, which we've seen in the editor previously. Yeah. You're able to tweak things while the app is running, which is very cool. And there's other benefits here that we'll just kind of skip over for this. So let's jump into Unity, and we'll see an example here. While I didn't mention it yet, we'll also take a look at what is the manual code to start with. Let's look at that. What is the manual code required to make that cube spin around? So we'll take a look at that so we have a starting point, and then we'll spend a little more time in the visuals since they're friendly for beginners. So we'll open up the Unity editor. I'll show the Unity hub actually, which is the welcome page. Then we'll open up a scene. We'll see some of this visual scripting in action. So when you first open Unity, it opens this splash page, which shows some different options you can have. You can install different versions of the Unity editor. So Unity is every month or so releasing a new update. So if you start a very big project in one version, you can decide to stay with it forever. but you can have multiple versions if you want to update and take advantage of the latest features. Then you'd have to do a little work to make sure your game can be upgraded, but it's usually pretty smooth. So in the year 2023 that we're in, there is a version 2023 that is out and available, but I work on a little bit older one that's more stable, 2022. So that's one of the versions here.
Okay.
Also here in the hub, there's lots of different learning resources you can use. So you can click around here and explore, learn the very basics of what the Unity editor can do, all the way up to really advanced features like getting your game onto a mobile device and taking advantage of the accelerometer as you spin your phone around, have that input into the gameplay. Lots of stuff you can do there. So we'll just open up the project that comes and is linked below. I've already got that running. So here inside Unity, I will open up a brand new scene. I did that by hitting Control N. You can also go to File and then New Scene. When you create a new scene, there's some different options here, but we'll just choose the basic one. And that basic one, what it's going to give us for free in what they call an empty scene is the camera to render and then the directional light. So that lets us see something in the scene. If that light wasn't there, we wouldn't see something. So that's why they give you those for basics. Now let's see what we could do here to create our own cube. We can right click, go to 3D objects and create cube. There's lots of different ones there, but for consistency, I'll just use the cube one. Then that cube sits there and we see it represented in the left in the game view. This is where the end user's experience is mimicked. So the camera's from one particular side. We see our cube there. And then there's the scene view. This is kind of a more powerful developer-only view. Whenever the end user is going to play your game, they're only going to see the game view. But you can use the scene view here to be able to line things up properly, change different settings. We could change the scale, for example, of our cube to make it much bigger or smaller. All those kinds of things you can do in the scene view. So what we're going to do, let me close the folder here, but I have an existing script here for spinning the cube around. We're just going to drag that onto, you could put it on any of these, but I'll put it on the cube since that's going to help us out. And we'll open up and we'll see what is the code that actually makes this happen. So first, let's look at the result. We'll hit play. So when you're playing, Unity does something. It darkens all the outer parts of the screen. You can still touch them, but they do that just to help you focus your attention. And you can tweak some settings if you like different color schemes than that. But the idea here while it's playing is that we should focus our attention on the game view or the scene view. And then when we unclick that play, now we're not seeing that light. We're not seeing that spin around. So here we're back in the editor mode of it all. So let's take a look at what the spinning cube is. Now, this is something I created before the video started, but it represents a complete, very simple project. Once it's loaded up, I'll bring it onto the screen here. So Unity has a couple core structural features. One is we're in a project. We're looking at a scene within that project. And then this cube is a game object. So those are some things that we've learned about before. And onto the game object, you can put your own custom scripts. So let me make sure we focus here on just the one at hand. So here is a complete script. There's even some lines in here that I think are best practices and nice to include that you don't necessarily need. But let's look at this like a complete one. I'll step through each of them. So if you're not familiar with coding in any language, there's some basics here that you would see are very similar to others. This language is called C#, and it is the only language you can use in Unity. So it's the letter C and then the pound sign, which, C#. It has its roots back in the C programming language, which was created over 50 years ago. And this is one that was originally created by Microsoft and is now part of Unity. Unity isn't directly affiliated with Microsoft, but they decided to use that language. I'd say in the world of 1,000 different programming languages, C# is one of the most common and it's one of the most powerful. So it's a good choice to have for game dev. So I'll step through some of the fundamentals here. First of all, we need to take advantage of some behavior that Unity gives us for free. So we use the using keyword and tell Unity, hey, we want to take advantage of your Unity engine library of code. So that's where this first line comes in. For basically everything you ever need to do in Unity, you're going to need that line because, of course, you're using some Unity stuff. Then you can think of a namespace like a folder, just a neat place to put the rest of your code. So in each file, you would have one namespace declared. You get to decide whatever name you want there. It's just to kind of help you, just like organizing files and folders. Okay. So I call this Rivello Multimedia Consulting, which is my company, RMC, then Level Up Africa, and then examples, right? So here we are in the meat of the particular example. What we're doing here is we're creating a new class. Now you can think of a class like a blueprint. It doesn't build the house itself, but it's a very important part of the recipe of when a house gets built. Yeah. So when we press play in Unity, we're going to be creating some code, just like creating a house. And this is the blueprint that tells more or less how that house should look in this example. Okay. So when we create that, we're able to take advantage of some built-in functionality. Unity gives us 3 different chunks of code that we can use if we want. You can see some of these are grayed out, and then this one is not grayed out. So let's talk about each of these. The first one is called awake. Now, when we hit play, the cube wakes up, and this code gets called exactly once. So you could imagine you might want to use this here to set up the cube, maybe set its size, maybe set rotation, but anything you want to happen exactly once. Then after the awake calls, there's the start that happens. That happens exactly once as well. It's kind of similar to awake, but you want to do anything one time that maybe connects with some other systems. So this cube in a larger project might need to know something about the character or the background. And whenever it needs to ask something about another system, you use the start. But again, awake is called once, start is called once, and that's it. They're never called again. We don't really need those in this particular example. That's why I haven't done anything interesting and they're grayed out. In fact, you could even just comment them out like that if you wanted to. So now the update. The update is the third one. Yeah. It's one of the most important ones you have available. This is called every single frame. So when the camera renders the scene, what it does 30 or 60 times a second is looks at all the 3D objects in the scene and decides how to render them out into pixels onto the screen. Okay. Every time it draws that once, this code will get run. So this is a great spot to do things like moving around, rotating, scaling, all that kinds of different stuff. So here, every single frame, we're doing one command here. I won't get into the details of it, but if we just look at it, transform, we've learned it a little bit, is the thing that's responsible for position, rotation, and scale. Yeah. And we're going to call something on it that helps us rotate it. And we'll pass in some details there. Then we haven't talked about this speed here, but that's what's called a variable in programming. So a variable is something that stores a value, and it's very important. You always want to have variables throughout your code. You can imagine playing a game and seeing that my character has 3 lives. So probably somewhere there's lives equals 3 as a variable, and that number can change over time. So here, I'm saying that the speed I should rotate around should be 2. And that's basically it. There's some other stuff I skipped here. But based on what we're seeing here, Brian, what are your thoughts? You have any questions?
I like how coding works.
Cool.
You just key in what you like in steps and then does the rest.
Yeah.
I think going forward, I would definitely have to learn a bit of this coding as well.
Yeah.
And this will be a very key tool when it now comes to coding, because I've realized this is where now most of the moving parts get moved from. So yeah.
Exactly.
It's really eye-opening, I'd say.
Cool. Yeah. So if we started only with the visual coding, which we're going to get to next, we wouldn't necessarily see all this stuff typed out, but this is what's happening under the hood no matter which way you program. So it's important to know a little bit about how this works under the hood.
Yeah.
So let's go ahead and run our scene, and we're going to do one additional thing. We've already seen our cube spinning around, but let's see what the speed is and how we can manipulate that.
Okay.
So we'll go ahead and back into the game and run. So here's the scene running again. And while it's running, I'm going to click the cube. Now we've seen that while the cube is running, we're able to tweak the position or the rotation or the scale.
Yeah.
We've seen that before. But notice also here, it's a bit dark, but there's the spinning cube script. And look what is exposed here. Brian, can you read that?
Yes. Speed.
Yeah, and this part?
The number, which is 2.
Exactly.
Yes.
So in code, we said we wanted a variable to store the speed. And we gave it a value of 2. Now, what's super cool in Unity is while it's running, I can tweak that number.
Increase it.
And we see it spinning faster and faster. So imagine all the different systems in your game, the character, the background, a ship that's shooting rockets, all that stuff. You can choose as a developer some of those variables to have over here and be tweakable at runtime. So as you play the game, you've got a character that's walking up to a cliff, getting ready to jump to the next cliff. You could tweak the jump value. You really want to tweak it to find the perfect value that works for your game and then leave it there forever. Yeah. It's kind of that way. You're kind of playing around with it, massaging it to find the perfect value. Okay. So here, I'm going quite fast, but imagine in a game where this was a tabletop and had a character on it. Maybe you'd want it going a bit slower, right?
Yeah.
So you'd be able to make that tweak.
Yeah.
So any questions? We're going to pop back to the slides, but any questions? Oh, actually, we're going to look at the visual scripting next here inside Unity. But before we leave the manual coding world, any other questions?
I've only seen the speed of rotation. Like, can you change the direction of the rotation as well?
Yeah.
Like we're going on this side. Also, even like just general change of direction of the rotation. That is possible to change.
That is possible too.
Yeah.
So there's lots of different values we could expose here that could help us do that. But quite simply, if we just move this in positive, we've seen it go faster.
Yeah.
But watch, if I move negative, the moment it gets negative, it starts spinning the opposite direction. Because if you think about it, always spinning positive is one direction. Yeah. Always spinning negative is the other one.
Okay.
But we could do some further tweaks to have it spin this way, or change scale, or move.
Or change scale and move at the same time.
Yep.
Okay.
Cool.
Yeah.
All right, so that's that demo there of the spinning cube. Now let's look at our visual scripting. So here we are in a different scene. I've set it up with a spinning cube already, but actually it's not a spinning cube, but a cube. And I've added some visual scripting to it. So there's a little bit of setup that I've already done ahead of time, including over here. We won't look at the details, but what I do want to do is open up the graph itself. And let's make that nice and big for us. So here is a visual drag and drop representation that, if you want, completely replaces the need to type any code. So we won't look at the details of all these nodes here. I'll just kind of give some highlights, and I'll also run it. So let's do that first, actually, because I think running it is quite cool. So we'll do that, and we'll do that. Just making a little room here. Okay, so I'm going to hit play. It's kind of small, but we got our cube up there at the top. Now I'm using the arrow keys, the up, down, left, right, to move the cube at runtime. Okay. And look at the little graph there. We can see some movement along those different connector lines indicating something's happening, right?
Yeah.
Now, each time I press these keys, what it's doing is taking my input and deciding how to move the cube.
Yeah.
So let's take a look at that code a little bit bigger here. Mm-hmm. So this is just a small sampling of what you could do. But you can say, okay, every update just like we saw in code, we know update happens every time the graphics render. So 30 or 60 times a second, depending on your game.
Yeah.
Every time that happens, we want to translate the transform or move the transform.
Yeah.
And then how much do we want to move it? Well, we want to move it based on the input. Shows a little game controller there. So grab the input in the horizontal direction. Grab the input in the vertical direction. We do a couple additional steps here, but eventually that input leads into the movement of that object. So you could imagine here, if we wanted to have the space bar shoot something, we could get the input from the keyboard or the controller for that, and then have something else happen. And this graph or diagram here would get bigger and bigger and bigger.
Yeah.
And your game could have multiple of these. There's a nice way to organize them so that you could have different areas. Eventually, maybe you fill the entire screen with different stuff.
Oh.
So some aspects of it are quite cool, that it becomes kind of, even if we don't exactly know what's happening here, we can see we're creating something, we're multiplying something, we're moving around. So now that you've seen a little bit of the code, and now that you've seen a little bit of the drag and drop, what are you thinking is interesting or cool about each of these?
I think from my point of view, the first one has more precision.
Yeah.
Like if it's numbers you're doing, if it's one, if it's negative, like everything is precise because it's typed down.
Yep.
On this one also it's precise, yes, but I feel you have a lot of freedom in the sense that you don't even have to have the values in mind all the time. You can just push and say, okay, I want this to move at this time and this to move at this time.
Yep.
So I think each and every one of them just applies now to you as how articulate or how precise do you want your actions to appear in the game.
Yep.
Yeah.
Yeah, I think that's very true.
Yeah.
Now, one of the things that's intimidating when you sit down to an empty page of code is you could type almost anything, including correct things and incorrect things. It's a little intimidating.
Yeah.
So what's nice about doing the visual scripting is just by right-clicking, I can see a list. So it's like what you see is what you get.
Yeah.
It's like painting by numbers. It's a little bit more predictable. So even as a newbie, if I want to do something related to math, I then jump into that. So it walks you through a series of menus and can feel a little bit safer.
Yeah.
So that's another reason it's cool for learning. Cool.
Yeah.
So we'll jump back into the slides and we'll learn a bit about some other ways we can use nodes and graphs inside Unity.
Okay.
Okay, so we're now going to talk about shader graph. So shaders are the instructions that tell Unity, in this case, as the camera's looking into the 3D world and it's about to convert everything to pixels, how exactly should it convert it? Now, if we had a green ball in the scene, we'd of course expected to draw a green pixel for the green ball. But, the ball might have darker parts and lighter parts depending on the light source. It might have different types of post-processing that does things like darkening and or lighting it. So here's a basic structure of all the graphical assets. So imagine in a scene, we've got a 3D model. Let's say we've got a green ball.
Yes.
So that's the geometry. That represents where in the world is the shape of that thing. So that's what's going to be rendered into pixels. But every model has a material related to it. Now, just like in the real world, we think of this table's made of the material wood. So that looks kind of brownish and it has a certain pattern on it. That's the same analogy we have here in the 3D world. The material is the container of instructions that decide what is the image to be rendered, and then what are the instructions for how to render that image. So a shader could tell that green ball be shiny or don't be shiny. So even though green ball is always the green ball, it's the shader that tweaks that and says, modify it, make it look wet, dry, et cetera, et cetera. Cool. So any questions about what we see right here?
No.
Cool.
Yeah.
All right. Now, just like we saw with the visual scripting, when we're talking about gameplay code, there is code being written under the hood. And in Unity, you can code this. It looks a little like C#, but it's actually not. It's something called Shader Lab that exists outside of Unity as well and is used in all sorts of programming. So remember before I said that probably you could learn visual scripting, but eventually you want to learn the coding because that's more flexible, more precise, as Brian said. Same thing here, except you could probably be a very powerful shader developer without the manual code, because a lot of the types of shaders you're going to want to do and add to are kind of more predictable. You don't need the full flexibility you do in gameplay development because you're going to be doing some pretty similar tasks. So for a lot of us, we don't need to ever step into this when we're making our first shaders. In fact, today we're going to skip this step and we're just going to show the next part.
Okay.
So this looks kind of like visual scripting that we saw a minute ago. It's some blocks of code. We're dragging lines between them, but this is actually Shader Graph. And it's going to decide what are the instructions that we should apply to this rendering of the object. Now there's lots of details on the screen here. You can pause if you want, but we're going to move into Unity and actually take a look. So in this demo, we'll open up Unity. We'll open up a scene that already has Shader Graph applied, and we'll take a look at how it works. Okay. Now, Unity comes with lots of shaders for free. So when you're sitting down to make a project, you never, ever need to create your own custom shaders. But just like when you have a box of crayons and you run out of the 8 colors that are there and you want a 9th one, that's when you might need to create your own custom shader. Yeah. And a lot of our favorite games have custom shaders to give kind of 2D cartoon look to a 3D game, or things that make the 2D game feel 3D, or creating water that looks alive. There's all sorts of reasons that you want to create your own shaders eventually as a game developer. Yeah. So popping back into Unity here, we've got a demo scene here that is called Example for Shader Graph. So I'm going to run the scene as it is. Yeah. Now, what we see here looks like one big blue space that is moving, translating, like maybe it's a cube that's moving. Yeah. But actually, when I was thinking about this simple space game, I thought, okay, I could create a really big cube and move it down forever and ever as the background of my space game. Yeah. Or I could just create one cube, never move it, and just have the texture move. And just have the texture move on top. Yeah. So let's take a look at how that would be done with Shader Graph. So first thing you do is you'd right click, and there's lots of different things you can create in Unity in your project. And some of them are related to shaders, and here we could create different shaders. Now I've already done that step, but you would do that first. Yeah. And then we would open up the shader. And here we go. We see something kind of like what we saw with the visual scripting. Trying to organize the screen a little bit better here. There we go. And this thing I don't think I need. Okay, good. So when you first create a shader, Unity gives you this stuff for free. Now we don't need to know all of the different details here because it's a whole science and art into itself. But shaders fall into categories like a vertex shader that affects the points of the geometry, or a fragment shader that is what colors to put in there. So if you'd imagine a game that had a character that was like vibrating, like maybe some kind of a space effect happened to them and they were vibrating, that would be a vertex shader because their geometry is moving. But in our case, we just want a big square background that doesn't change its size. Yeah. We just want to do something with the pixels. So based on what you see here, and here's the little spoilers, there's a line here. Which of these do you think we're doing, vertex or fragment?
Vertex.
Okay, and why do you think that?
Because I'm looking at I'm trying to look at the how it's moving.
Yeah.
It doesn't look like it's almost continuous, even though it's continuous. And how do I put it? Like it's a path, but as I'm seeing the clouds unfold, it's not the same pattern, it's changing. So it goes big, it goes big, but the pattern is not the same. You know, in some games like Subway Surfers say, for example, the trains, buildings, gap, train, buildings, gap.
Yep.
Something like this. So maybe I'm wrong, but that's...
It's a very good guess. And we could get this result by actually changing the geometry.
Oh.
You could think about, which is the vertex one. The vertex is about changing geometry.
Yeah.
You could think about having the object kind of fold over itself or something like that.
Okay.
But the clue here is that there's a line only drawn to fragment. So the answer here is fragment. So fragment is changing the colors applied, the pixels being rendered. So not the shape, but just the colors.
Just the colors.
But it's cool that you could do both. If we drag something over here, we could change the position, the normals, the tangents, which are some shader related terms.
Okay.
But here we're just doing the fragment. Now I'm not going to create this live or explain all the details, but let's just go over it. Yeah. So working backwards, which color should be applied? We say, well, we have a cool blue and black space background. So let's apply that graphic.
Yeah.
Then to actually get it moving, we're going to use some coordinates here, and we're going to pass in a lot of different stuff here. Yeah. It's going to get a little bit of the time so that over time, we're going to make some changes.
Yeah.
We're going to apply a scroll speed. So kind of like when we talked about that cube spinning, we decided to make a variable out of that. Yeah. We've got that here. Okay. And it's doing some other computations along the way, right? So it's a pretty complex topic, but you could see that with dragging and dropping, once you know what you're doing, you only need 6 or 7 steps here to do this.
Yes.
Other things we could have done here, we could have made it shiny, we could make it glow, we could have outlines around shapes, you could make a 3D game look 2D, you can do lots of different stuff, right?
Yeah.
But this is all we're doing here. Now, the scroll speed that I mentioned, which is shown here, let me show where that shows up in the game. So when I choose my background in the scene, and we've seen that there's some details we can tweak about these kinds of things over here. We've got down here where the shader lives, we've got the scroll speed. So while it's running, I could tweak the scroll speed and have it move a little bit that way or a lot that way. I could change the speed. You could make it go a little bit faster in the Y direction. You could also tweak how it tiles. So maybe you want to have, a checkerboard pattern be tiny checks or expand the checks. So you can decide as a shader developer, what are the things that might want to be tweaked at runtime? So imagine if we're a ship and we're flying through the space world, you might want the background to move slowly sometimes or fast sometimes, depending on the speed or difficulty of that level. Okay. So just by designing it the way we did, we could, within code, we could be tweaking this value to go faster and faster. That's a little too fast, but let's say even this is probably the fastest level right here.
Yeah.
Right?
Yeah.
So that's it. That's all we're going to see with Shader Graph. So we've seen that there is some code under the hood that's called Shader Lab, but we don't need to touch it. We can drag something into the scene, create a custom behavior of how those pixels should be rendered, doing things like constantly scrolling here. We did see, as we were talking, that you could have solved this different ways. You could have the geometry move. Just to be sure, you can see that this is one static cube, very thin cube in the scene, and all we're doing is moving the texture on it. A different solution, as I was saying before, if I didn't want that, let's just say I decided not to animate it that way, so it's just static. I could make it super, super tall, like that, and then just move it. So we've seen how to spin a cube. We could probably learn how to move a cube, and we could have done it that way. But the nice thing here is it's just one more thing, one more recipe that we can pull off the shelf. So when we're sitting down to code, we do our gameplay with the visual scripting, and we do our shaders with the shader graph. Cool? Any questions about that?
Good.
Okay.
Yes.
So we're going to look at one more type of visual scripting. So back here in the slides, we're going to look at the VFX graph. So in this picture, this is a sample of some of the type of effects you could imagine. So if you wanted to have magic in a game represented as spells that you're casting, lightning that you're shooting, that's a perfect place to look at visual effects. Under the hood, what's really happening is that there's many, many tiny images that all together help tell a story.
Yeah.
So when you think about smoke in a game, it might feel like one blob of smoke, but it's really lots of tiny little smoke bits that together give you that impression, right?
Yeah.
So here we have things like different space vortexes, some fire, some lightning, all that stuff's possible.
Yeah.
And what VFX Graph is using under the hood is particle systems.
Yeah.
So particle systems are rendering tiny, tiny images in a group, maybe 5,000 of them, in order to sell a convincing effect. Cool. So let's take a look at how we can do that. Now, one of the ways you can do that is with the VFX graph. Now, before with the visual scripting and with the shader graph, we saw that there is a way to code it if you wanted to. Here, there isn't really that same entry point. Here, for all your visual effects needs, you only do this one here, right? So there isn't a code way to learn. But you can see in the diagram there, it's a similar blocks, dragging lines, different relationships. So there's some similar feel to what we've already seen. And we'll take a look at how that works in the code here. So we'll open it up. We'll see a scene that has some VFX in it.
Yeah.
We'll look at the graph of it itself, and we'll just step through a couple of the details there.
All right.
So here we have this scene for VFX. So imagine in a game, you wanted to be able to shoot rockets. So in one of these scenes, we've got a more complete space game that includes that graph, the shader graph in the background as the scrolling space, and your character can shoot rockets. Now, each of the rockets could have no effects applied, but as a way to showcase what we can do here, I've applied a couple of effects.
Yeah.
What do you see when what's coming out of the tail of the rocket there?
So, as a gamer,
Yeah.
okay, as a person, first of all, I'd say the rocket is boosting, right? It's going, there's smoke, there is flames.
Yep.
If you played FPS, you'd tell that's a gun shooting down. So it just depends on how you see it. But again, it's flame coming from the propeller. No, is it a propeller? From the boost of the rocket.
Yeah, like the booster. You know.
Yeah.
So let's take a look at how something like that would be created. Well, in this scene here, we've got a rocket.
Yeah.
And we've talked a bit about game objects being a very important central piece of Unity. And if you want them to be reusable, you can create a prefab. So the way you can tell the difference in Unity is if it is white text, it is a game object. If it is blue text, it's a prefab. And the only difference is a prefab is a reusable game object. So you just think of it like that.
Yeah.
So I created a rocket that is a prefab. And the idea was we might want to have more than one in the scene because we want to shoot them like a bullet. So the way that the rocket is structured is within it, it has smoke and sparks. So when Brian explained the smoke and the fire, there's the smoke and the sparks. So let's look at how that's structured. Well, there's a visual effects that's dragged on. And if we click at the definition of that, it's going to open up. And it's going to show us our diagram. I'm going to make it, actually, let me reorganize the screen here for a second. This one I don't need.
Oh.
It's actually a little off center. I didn't realize that. Let's look at it this way. Yeah. So here I've decided to split the screen up so that we can see, okay, I'll zoom out a little bit just so we can see the overall scope here.
Yeah.
These are all the nodes that help one of these effects, just the sparks happen. So we can see the sparks, there's a lot of them. They're quite fast. They're reddish and whitish. They're kind of glowing. And some of them kind of fly away, kind of like sparks from a campfire or something. So all that is done inside here. So when you create a brand new effect, Unity gives you a bit of spawning. So that is how many should we create?
Yeah.
Then when that thing gets created, what size should it be? What speed should it be going? That goes into this block.
Yeah.
Then every frame, we've learned a little bit about update, happens every single graphic frame.
Yeah.
What do we want? We want to apply some gravity, we want some force, we want some drag. That means it slows down over time.
Yeah.
And then finally, when we output it, we can give it a different color or shape or a look, and all that stuff gets passed in. So there's lots of details into how this is created.
Yeah.
And the exact same type of graph can create smoke, fire, magic, those graphical vortexes, all those things we saw before, just by tweaking the values.
Yeah.
So let's look at what are the values we could tweak here. Let's say we wanted it to move a little faster or a little slower. We can go, just going to reload the original layout here and click on the rocket that's in the scene.
Yeah.
And look at the, oops. Got to figure out where I put this stuff. Okay, here in the sparks again. So here on the right are all the different settings. This is more than we've seen from our spinning cube example, more than we've seen from our visual graphing and shader graph. So there's lots of different stuff here. Now, as a developer of particle effects using VFX graphs, you could decide, I don't want it to be customizable. I want one type of sparks and that's it.
Like that. Yeah.
Or you can have more and more of these values. So you can see there's a lot of them. Let's say I wanted to change the gravity vector. I could do that. I could turn some things off. I could give it more or less initial velocity in different directions. So here it is not quite has as much velocity. Here it has a much stronger velocity.
Yeah.
So you could imagine in gameplay, that's something you might want to tweak so that slower rockets have a different look than faster rockets. Right?
Yeah.
So let's just take a look at the smoke one. I'm going to turn this one off just so we can concentrate on the smoke. The smoke is especially cool. Man, it looks really nice, right?
Very real.
Very real.
Yeah.
So here we can give it a lifetime where maybe we have the smoke stay on screen for a longer period of time,
Yeah.
or a much shorter lifetime. Let's see if we can see the effect of that there. So now it looks like it's just alive for a split second.
Yeah.
Right?
Yeah.
So that's it. That's all we're going to look at here. You can see how we did sparks, how we did smoke, but you could do tons of different stuff here. Unity lets you do all of it.
Yeah.
Now, imagine in a larger game project, you're definitely going to need to do that gameplay code, but you don't necessarily have to apply any visual effects or any custom shaders. That depends on the needs of your team. Cool. Before we pop out of Unity, do you have any questions or thoughts about what we're seeing here with VFX?
Maybe just a comment.
Yeah.
I love how everything works.
Awesome.
I mean, now it puts that big question of order. How does this get to move? How does this get to work? So when on this page you see a lot and you're like, oh, now that makes sense now. Yeah. So personally, I'd say it's mind blowing.
Awesome. Well said.
Yeah.
All right. So mind blowing. Let's see if we end up here. We just did our recap there. So we'll end the section here. So in this, I'll do a little recap. We looked at what is coding. Why is it important? That for many different areas of Unity, you can manually type it or you can do the drag and drop. That for the gameplay code, you could learn with the visual way, but probably you're going to need to learn those manual coding skills in order to be a competitive game developer. But for the visual effects and for the shaders, you can do a lot on a team really nicely just with those drag and drop nodes. So lots of cool options there. All right, that's it for this video.